Okay, good day, guys, and welcome to Internet Academy. So today we're going to be talking on thermal stresses and strain. Now, first of all, we should know and have an idea of what thermal stress and thermal strain is. Now, from a definition we said earlier in our first video, that stress is what? The force over what? Per unit area. So take note, thermal stress is the stress that results from what? Heat. Take note that thermal means what? Heat, and stress, we defined that earlier. So it is then applied in the same case, just that the formula for the thermal stress is different from stress. And the formula for thermal strain is different from what? Strain. Now take note, let's consider a rod or a metallic substance subjected to thermal stress or anything, which is heat. You see that the original length before the heat was subjected to this material was L, which is the original length. The final length after it had been subjected to thermal stress is LO, where the original temperature, which is the initial temperature, is θ1 and the final temperature is θ2. Take note that we have the linear expansivity. So we have linear expansivity denoted by this symbol. So we have the linear expansivity is equals to what? The final length minus the original length over the original length bracket θ2 minus θ1. Now, take note that extension is final length minus original length. So we can denote this by what? Extension all over the original length. Now, θ2 minus θ1 is changing theta. So we have this. Now, let us separate this and let's leave this as this. Now, does this look very familiar to you guys? Now, if it doesn't, take your time. We know that strain is what? Extension over what? Original length. So we need to substitute this value into there. So we have a linear expansivity is equals to, we're going to substitute this as what? Strain. So we're having this strain multiplied by 1 over change in theta. So we have our linear expansivity as the strain over what? Change in theta. So when we come here, when we cross multiply, which we move this to this side, and take note there's always a 1 here. 1 will multiply the strain and it will still be strain. So we have that the strain is given by what? The linear expansivity multiplied by what? The change in theta. Take note of this expression. Let's call this equation 1. Take note that this is called thermal strain. Thermal strain. So this is the expression and the formula for thermal strain. The strain subjected to what? Temperature. Now, it's very, very important that we know the units of these parameters. So before we go into the expression for the thermal stress, we should know that this is expressed in meters, which is this length are expressed in meters. These are expressed in degrees Celsius. Take note that the expression for this is per degree Celsius. That is the unit for linear expansivity. Take very note of that. So now we have that from Young modulus. So we have from Young modulus, we have that E is equals to the stress over the strain. Now let's make the strain subject formula. So we have that the strain is equals to what? The stress over E. Now substitute this expression into here. So anywhere we see the strain, we multiply it as what? The stress over the Young modulus. So we're having the stress over the Young modulus, which is capital letter E, is equals to linear expansivity multiplied by change in temperature. So once we cross multiply, we have that our stress is equals to the U modulus multiplied by the linear expansivity multiplied by the change in temperature. Take note of this formula. Let's call this equation 2. This is known as what? The formula for thermal stress. Very, very important. So these are the expressions for thermal stress and strain.